So questions from the homework from last day. 4C, a ladder whose distance from the base to the wall is 1/4 of the distance up the wall. Say what? I need to draw a picture. Ladder. Oh, you know what? Let's do it as a positive slope. I'm a lefty, so I tend to draw my lines that way. You guys would probably draw that. I need to draw it a little smaller. Or you know what, Mr. Duick, move it over. Here we go. I think here's the ladder, Darian. Right there. You okay? And it says the distance from the base to the wall is 1/4 of the distance up the wall. Say what? I'm going to make up a number. I'm going to say that this distance here is 8. Why 8? You'll see why in a second. What's the base? Well, the base apparently is 1/4 of 8. What is 1/4 of 8? Ah! You see why I picked 8? I figured I may as well pick something that 4 goes into and hope for the best. Hey, what's my rise? What's my run? Now, that's not what they have in... Oh, what's 8 over 2 in lowest terms? That's what it says in the back. Hey, what if you hadn't spotted that? What if, Mr. Duick, I had, instead of using an 8, what if I had put a 4 there? Well, if the base is 1/4 as long, what's the base now? 1. What if I had put a 12... Mr. Duick. What if I had put a 12 right here? It'd be a 3. I still get the same answer. Now, really, because I'm a math nerd, here's what I would have said. Apparently, this is 1/4 the distance, so I guess I can put a 1 and a 1/4. I'm comfortable going 1 divided by 1/4 and getting 4 because I don't suck at fractions. I know that many of you guys do suck at fractions, so you might have chosen to avoid it. It's 4, though. Mr. Derek, are you going to give us one like that on the test? Probably not worded that strangely. Instead of 1/4 the distance, I would probably say that the height was 4 times larger and avoid the fraction, which scares you. Any others besides number 7? Number 7. Anybody get number 7? Oh, yeah. 5? So find the slope of each section of the hiking trail. For clarity, I'm going to go like this. A, B, C, D, E. Because then I can find the slope of AB. Isn't that a nice way, a short way to write a lot of information? Subscripts. Okay, slope is what over what? Rise over run. What's the rise? Don't say 1 because each square here is not worth 1.
200.
Huh?
200.
The rise, I think each vertical square is 200 over. What's each horizontal square worth? Not 1.
3,000.
I think the slope of the first one is going to end up being 0.2 or 1/5. I don't know what it has in the back. Does it have it as a decimal or does it have it as a fraction? 0.2, they did it as a decimal. Darian, is that okay?
Yep.
Could you do the rest of them yourself, you figure now?
Yep.
Yeah. So for what it's worth, 2 squares. Each square is, the rise is 400, the run is 1,000. Hey, this is going to be a negative slope right here. Rise over run. Also a negative slope right here. Rise over run. And I guess that would be the, I don't know. Is that all right? Number 7. It says the slope of a ski hill is 1/3. Cool. The coordinates of the bottom of the hill are 2, 5. What is the value of y if the coordinates at the top of the hill are 8, y? Amy, did they give me a graph? Can I just go, hey, rise over run? This is a job for the slope formula then. This is a job for me to use that bad boy. I'm going to call this first x, first y. I'm going to call this second x, second y. Why? How come? I don't know. I got to do something, Greg, and I'm stubborn. I've written something down. I feel better. Ooh. Let's try plugging all of this into the slope formula. First of all, this question does tell me the slope. It says it's 1 over 3. Cool. What's y2? Because I asked you to. What's y? I'll never get tired of that joke. Yeah. Apparently that's y2 minus. What's y1? Over. I still don't know where I'm going yet, but Marcus, I'm going to try something. What's x2? Minus. What's x1? Oh, you know what? I can tidy up the bottom. What is 8? Take away 2. Okay, I'm going to go 6. Now what? In grade 8, you learn a handy-dandy, wonderful little trick when you have one fraction equals one fraction. Do I have one fraction equals one fraction? I do. I think it's in grade 8. You learn a way to turn this into no more fractions. You guys know this word here? Who has not seen that word before? Maybe you guys don't do it in grade 8. You guys, what was that? It said if you have one fraction equals one fraction, you can get rid of the fraction by multiplying diagonally. In other words, by rewriting this times this. In your head, Anthony, what is 6 times 1?
6.
I knew you could. Equals this times that. I'm going to write 3 bracket y minus 5 because that's how I write times. Oh, I like this question. I like this question. I like this question.
Can you be on the test?
I didn't say that. You're just a good student who notices things. Now what? Now what? Got to do something. I'm not going to freeze. Now what? Absolutely. We're going to get rid of brackets. We're going to distribute. We're going to front door, but whatever your teacher called it. If I'm solving an equation now, and I am, I need to get rid of brackets. So I'm going to go chunk. I'm going to multiply the 3 onto the y and onto the negative 5. And Simi, apparently I get this, yes? What am I trying to find?
I'm trying to find the y.
Let's get it by itself. How?
Add 15.
Plus 15 to both sides, yes? I got to move over here. And it looks like I'll get a 21. Yeah. Equals. Now what? Now here's the question. Think about what I just did. Did I really do anything new there? Did I teach you anything new? Did I do? This is why the grade 10 provincial is so tough, because there are questions where you need to be stubborn and clever, and I can't predict every single one of them. Sorry. But Alex, I would argue I didn't do a single new thing there. In fact, Brianna, I would argue I was stubborn. I wrote down, since they said slope, and I didn't see a graph, I wrote down the slope formula in desperation. Then I said, well, I may as well try and plug whatever I can into there. Oh, they told me the slope. I replaced the m with a 1/3. And then when I got that, I pulled out some Math 8. I cross-multiplied. Holy smokes. Who knew Math 8 was still useful? Oh, and then I pulled out some Math 9 equation solving. Got rid of brackets. Thank you for coming through, guys. Like, really? Everyone forgot? Thank you, Cindy. And, yeah. There you go. Any others? Lesson 2. So we're looking at two types of slopes, parallel and perpendicular. I wrote first, let's remember the definition of parallel and perpendicular lines from grade 8. Maybe you don't do that in Math 8 anymore. I think you're supposed to do some geometry in Math 9. I'm not sure if they are or not. So I'll remind you. Parallel lines are two lines in the same plane that never touch. They're at the same angle. They go off to infinity and never touch. Perpendicular lines are two lines that cross each other, but they cross each other at 90 degrees. Brody, not perpendicular. Right about there. Ish. Perpendicular. In the space provided, find the slope of the pairs of lines. What do you notice about their slopes? What's the slope of AB if you go rise over run? Positive or negative?
Positive.
What's the rise? 3. What's the run? What about CD? Positive or negative? What's the rise?
6.
What's the run? Oh, what's this in lowest terms? What do you notice about their slopes? And they're parallel. Maybe this is overly obvious, but it turns out, Curtis, if you know two lines are parallel, you know that their two slopes are the same. In lowest terms. Let's convince ourselves with EF and GH. So GH is really easy. I think it's negative 1 over 3. EF is negative 2 over 6. Yes, if I count rise over run. But in lowest terms, Brianna, what is negative 2 over 6? Negative 1 over 3, right? So AB is parallel to CD, and their slopes are the same. EF is parallel to GH, and their slopes are the same. What about two lines that are perpendicular? Now, I made sure these sets of lines are perpendicular. First of all, let's be obvious. Are the slopes of perpendicular lines going to be the same? No, in fact, you know what? I can tell you that one of them is always going to be positive, and what's the other one always going to be? There's no way you can have one going uphill without crossing the other one downhill 90 degrees. Let's see if we can spot a pattern. What's the slope of AB? Negative. Negative what? 2 over 3. What's the slope of CD? Positive. Anybody see any pattern there? Ooh! What? He used the math word. He used the math word, reciprocal. Remember that from when you did fractions? In fact, the phrase we're going to say is parallel lines are negative reciprocals. Negative opposite signs. One positive, one negative. Reciprocals. Nice. Take two. Take two. We haven't proved it yet. You know what? Let's try the next one. If it works, I think we'll trust it. Proving this is much more difficult, but I think we'll say we spotted the pattern. We're good. Let's try this next one. What's the slope of EF? Negative, sorry? 2 over 6, which in lowest terms is negative 1/3. if this pattern holds and if GH is perpendicular, what would you expect the slope of GH to be? Positive 3 over 1. Let's see. Is it? Ooh. So, AB is perpendicular. Okay, first of all, the words is perpendicular to, too much writing. There's a symbol for it. The symbol for perpendicular is a horizontal line and an upside down capital T. Two lines that are perpendicular to each other. I'll probably start to use that because I don't feel like writing is perpendicular to, and perpendicular is a tough word to spell. There's also a symbol for is parallel to, by the way. The symbol for is parallel to is two slanty sideways parallel lines. And parallel is even tougher to spell than perpendicular because it's got multiple R's and or L's or something. So I'll probably tend to use that. Anyways, AB is perpendicular to CD, and their slopes are, what did we say, Alex? Negative reciprocals, flip it. Negative, opposite sign. If your original slope is positive, the perpendicular will be negative. If the original slope was negative, the perpendicular will be positive. That's why we lump that in, and we don't mean the answer is always negative. We really mean opposite reciprocals. Oh, EF is perpendicular to GH, and their slopes are also negative reciprocals. Alon, that's actually kind of neat because one of the things that's going to let us do then is prove that two lines are perpendicular. How? Find their slopes. How do we find slopes? Slopes are what over what? Rise over 1. Or if I don't give you a graph, if I give you the point slope formula, and then you just look at your answer in lowest terms. If they're negative reciprocals, they have to be perpendicular. If they're not, they can't be. Or it also, Greg, lets us prove two lines are parallel. If they're parallel, what do you know about their slopes? No? If they're parallel, what do you know about their slopes? They're the same in lowest terms. It's actually a very, very powerful tool for math nerds. So, when lines are parallel, their slopes are the same. When lines are perp, their slopes are, you know what, instead of negative, I'll write the word opposite and reciprocals, but I'm going to say negative reciprocals. Example 1 says the slopes of lines A and B and C are given below. Lines A and B are parallel. That's probably important. While line C is perpendicular. Fill in the chart below. All right. The slope of line A is 2 over 5. What's the slope of line B if it's parallel?
2 over 5.
Yeah, that was a little slow, folks. Thank you, Jordan. What's the slope of line C if it's perpendicular? Careful. Not 5 over 2.
2 over 5.
Not 2 over 5.
Negative 5 over 2.
Huh?
Negative 5 over 2.
Opposite reciprocal. Change the sign, flip it. Ooh. What's yucky about the way they gave me the slope for line B in the next line? Okay, let's write this as this is, by the way, a proper fraction. I hate proper fractions. I don't like mixed numerals. To me, they're not very useful. I much prefer improper fractions. How would I turn that into an improper fraction? Do you remember? Yeah.
Plus, like times the left number by the denominator.
That times that
Yep.
plus that,
Yeah.
but negative.
Yes.
What is 3 times 3?
9.
Plus 1?
10.
This is negative 10 over 3. Line A is parallel to line B. What's the slope of line A?
Negative 10.
Negative 10. over 3. Line C is perpendicular to line A. Careful. What's the slope of line C? Positive 3 over 10. I normally wouldn't write the plus positive, but in our notes, let's do that just so that we know we did change the sign. As a reminder, that doesn't look like a 10, does it? Let's try that again. Next line. What's the slope of line C as a fraction? Okay, it's 7 over 1. Yes? What's the slope of line A then? Negative. Flip it. Negative 1 over 7. What's the slope of line B? Same as line A because they're perpendicular. Oh, sorry, parallel. That's why I use symbols. Example 2 says, find the slope of each pair of lines. So we'll find the slope of WX, we'll find the slope of AB, then state if they're parallel or perpendicular. Okay, I'm going to zoom in a little bit. I think I can. Yeah, that works. And I'm going to go draw a little line. First, I'm going to find the slope of WX. How about I call that MWX? You know what? We need the slope formula. How about at the top of the page right here, let's write the slope formula. That was y2 minus y1 over x2 minus x1. Yes? x1, y1, x2, y2. So how can I calculate the slope of WX? What's y2? Minus what's y1? Over what's x2? Minus what's x1? I get 9 over negative 12. First of all, is this slope positive or negative? 9 over 12 in lowest terms. What can you divide the top and bottom by? Well, 3. So the slope of WX is negative 3 over 4. If AB is parallel, I'm expecting the same answer. If AB is perpendicular, what am I expecting for an answer? Positive 4 over 3. Right? Change the sign and flip it. Negative reciprocal. Let's find out. I'll change colors. The slope of AB, x1, y1, x2, y2. I have the slope formula at the top of the page. y2, negative 2, minus y1, 10 over x2, negative 7, minus x1, 2, equals negative 12 over negative 9. Yes? What's a negative divided by a negative? What's 12 over 9 in lowest terms? Are these lines parallel? Are these lines perpendicular? Yes. Ah! So you ready? Here's how we can write that. WX is parallel. Oh, no, not parallel. What was the symbol for perpendicular? Upside down capital T to AB. And Amber, we just proved it. They're negative reciprocals. Yonk. I'm going to guess this one is either parallel or nothing. Let's find out. Let's find the slope of ST, where that's x1, y1, x2, y2. Slope is y2, 5, minus y1, -1, over x2, 1, minus x1, -2, do you get 6 over 3? Or in lowest terms, 2? Yes, it's over 1. Yeah? That was so much fun. Now let's find the, I'll change colors, slope of UV, where that's x1, y1, x2, y2. y2, 3 minus y1, -1, over x2, 4 minus x1, 2, and I get 4 over 2. Or in lowest terms, Jordan?
2.
Woohoo! Are these lines perpendicular?
No.
Are they parallel?
Yes.
How do you know?
Same number.
Same slope. Hey, what do those 3 dots mean? You seen those yet? Ooh, am I showing you some new notation? So you'll start using this in science next year quite a bit. 3 dots. That's an abbreviation for the word therefore. So we showed the first line has a slope of 2. Yes, Jordan? We showed the second line has a slope of 2. Yes, Jordan? Therefore, ST is parallel to UV. And Garrett, we didn't need to get a piece of graph paper. We didn't need to get out a protractor. We didn't need to measure angles. We've done it as a proof. Example 3. Find the value of K, which obeys the following conditions. The slopes of parallel line segments. You know what? I think this is an important word here. Are 3 over 8 and 9 over K. If they're parallel, what can you tell me about the slopes of this line and this line? They are this. What? Ooh, he one-upped you because he actually turned it into an equation. What did you say? They are
Equal.
Are you saying then that I can write this with an equal? Are you saying then that I now have 1 fraction equals 1 fraction?
Yes.
It would be wonderful if there was a grade 8 mathematical operation that I could pull out of my back pocket that allowed me to somehow deal with 1 fraction equals 1 fraction. Perhaps an operation that we used 2 words to describe, the second of which was multiply.
Cross multiplying?
Really? We can cross multiply here too, Marcus? Are you saying I can go like this? Change colors, Mr. D. Are you saying I can go like this? And like that? Are you saying I can say that's going to be 3K? Because that's what 3 times K is, because I do find it easier to multiply letters than numbers. Equals 9 times 8. 1, 2, 3, 4, 5, 6, 7, 8. 72. Is that right? Yeah, that's right. Now what? $72 divided by 3. 24. Double check me.
Yes.
Yeah. Here you go. B. The slopes of, perpendicular line segments. That's the key word. Are 1 over 3 and k over 5. Are these two slopes the same?
No.
Because they're not parallel. What are they then? Well, the phrase I've given you is negative reciprocal, opposite reciprocal. To solve this one, Marcus, first of all, start out by writing down the slope with the variable in it. Marcus, what is the slope that has the variable in it? Write that down. And an equal sign. Except, I'm telling you, it's not equal to 1/3. If they're perpendicular, what is it really equal to? Ooh, nice! Okay. By the way, you could have written down the 1/3 and then taken the negative reciprocal of the k over 5 and written it as negative 5 over k, but I found moving the letter around freaks the kids more, so I just say write down the one that's got the letter in it and do negative reciprocal of the one that's got all numbers. Brady, do I have 1 fraction equals 1 fraction? Oh, you don't say. Brady, does there exist some kind of grade 8 mathematical operation that I could, I don't know, I'm just saying, pull out of my back pocket, maybe 2 words, the second of which is multiply? Really? What is that operation, oh pray tell? So are you saying that I can go times, and now get 2 sides of an equation? Brady, in your head now, what is 1 times k? I didn't write the 1. That's okay. K? No, sorry. Equals? All right, let's get the k by, oh, pa. Already is. If there was a coefficient, I would now divide or whatever I needed to do, but it already is. Wow, that was a short lesson. There are a few weird curveballs in the homework, and I'm deliberately going to see if you can figure it out. One thing I haven't done is given you, just like in number 7, last assignment, a missing variable, solve for y. And I think there's some like that to try in the homework. See if you can figure it out. Homework, number 1. 2 is good. 3 is good. May end up assigning most of this. Yeah, 4 is good. Yeah, 5 is good. Yeah, 6 is good. Are you going to assign all again, Mr. Duke? I don't know. 7 is a nice application. Sure, let's do 7. Get to practice plotting some points and stuff. Nah, 8. I'm going to skip. So how about 1, 2, 3, 4? You know what? Do any question that's not a perfect cube. Oh, except 1 is a perfect cube. Do any question that's not a perfect cube except for also do number 1. Because 8 is 2 cubes. Surely there has to be one less than 2 cubes. Oh yeah, 1 is 1 cube. I thought I was so clever and that flew in my face. Jeez, Duick.